And so this is the one problem I gave you to do yesterday. So of the 26 of you that joined, 9 of you decided to do it or even start it, which is kind of depressing. Okay, I gave you one problem to do. That was it. So thank you to the 9 of you that tried it. The rest of you guys, get it done now or fix your work now. So we learned yesterday about recognizing when a right triangle is an isosceles right triangle, which means that the 2 leg lengths are the same length and the 2 acute angle measures are the same measure. When that happens, and when we have an isosceles right triangle, there is a special relationship between the leg lengths and the hypotenuse. And so just to review with you guys from yesterday what that means, you can see here we have a diagram where the right triangle has 2 45-degree acute angles, and X represent that these 2 legs are the same length of whatever X is. And the special relationship with the hypotenuse is that the hypotenuse is exactly square root of 2 times as long as each leg. So if you know a leg, all you have to do is multiply the leg length by the square root of 2, and that will give you the hypotenuse length. All right, so this is what we were learning yesterday. We looked at an example. We did this one together, and then you were to try this one. So I want to show some of your responses. This first person here, they recognized that they were given a leg length of 4 square root of 3. And well, since this is an isosceles right triangle, it's a 45, 45, 90 triangle, that means this leg is also 4 square root of 3. And so they wrote that in. And then this hypotenuse is unknown, they have a question mark. Question mark is equal to, well, they know that if they take the leg length that's given and multiply by the square root of 2, that's going to equal the hypotenuse length. That's absolutely correct. And then what they did is they took the square root of 3 times the square root of 2 and put it inside a radical symbol as 1 square root. Okay, and then simplifying this, 3 times 2. I can't pull anything out because I don't have 2 of the same factor to pull out. So we're just going to leave it as square root of 6. So the correct answer here for the hypotenuse is 4 times the square root of 6. I couldn't really do this any better. Okay, this is perfect. And this is exactly what you want to have. If I look at some other examples here, so this person here, they went from JL is equal to JK times the square root of 2. That's absolutely correct. This is a very absolutely true equation to start with. I do like that they used the vertices in this equation. So that's how I can make this one better, is if you started with JL equals JK times the square root of 2 up here. Okay, they did that. And then they replaced or substituted out the value of the length of segment JK with 4 square root of 3 times square root of 2. Something they did here is they rounded though. So it's tempting to round. And if I do round 4 times the square root of 6, let's see, what is the square root of 6? 6 is not a perfect square, so this is an irrational number. This decimal goes on forever, never ends. If I multiply that by 4, 9 point something, something, something. And so they did round correctly if the directions were to round to the nearest tenth. That would be absolutely correct. But if it doesn't ask you to round, then you should leave your answer as an exact answer. Okay? If you were asked to round, this would be correct. If you are not asked to round, this is correct, right? I'm not, on a test, this would probably be something that you would lose minimal points for rounding when you weren't supposed to. See, so this person, we went through and we did set up the initial equation correctly. We did substitute correctly. They did create the square root the right way. They have 3 and 2, and they also put a factor of 1, which is not wrong. You can multiply by 1 anytime you want. But I can't pull this 2 out. The reason why is that you have to have 2 copies of a factor to pull it out. Why do you multiply it by 2? Andres has asked in the chat. By the square root of 2? Is that what you mean, Andres? Or a different 2? So this is where the mistake was made here. Where did you get the 2 from? This 2 that I'm pointing to? Or the square root of 2 on mine? I haven't shown mine. These are all your guys' own work. So this one, the square root of 2 here. Okay, so good question. This comes from, if I come back here to our vocabulary, this comes from the definition of an isosceles right triangle. So if you have an isosceles right triangle, there is a relationship between the leg lengths and the hypotenuse. The leg lengths will always be congruent. They're the same measure. And the hypotenuse will always be exactly the square root of 2 times as long as the leg length. That's where the square root of 2 comes from. Okay, good. Good question. Coming back here. Let me see. So that's just something to be careful of. Only pull out if you have 2 of a factor when you have a square root. And so I think we're ready to move forward to what we're doing today. Okay, so this video here, I only wanted you to watch the first 3 minutes. We are going to rationalize some denominators. You're going to see that today. And this is our first example. And then you will have one that you do. Okay, so if you take a look at this right triangle, the 2 acute angles are given, and they are both 45 degrees. So right there, I know that this is an isosceles right triangle. In an isosceles right triangle, these 2 leg lengths will be the same measure. They're going to have the same length. Also, I know there's a relationship between the hypotenuse and the leg length, where the hypotenuse is exactly the square root of 2 times the leg length. So for this one, I'm going to kind of switch what I'm projecting. Give me a second here. So I am going to use some colors just to identify some things. So one thing I'm going to do is draw on the hypotenuse and show that that's what the hypotenuse is. That's what this 10 represents. That is the length of the hypotenuse. And then for those leg lengths, well, I'm going to use the same color for both legs because they are the same length. Okay, whatever they are, they're the same. So I could introduce a variable if I'd like to, like x. And then I'm going to set up an equation to represent this relationship I have. Now, I know that up here, x, oops, pen's changing on me, x times the square root of 2, that is the hypotenuse. But the hypotenuse is also 10. So basically, x times the square root of 2 is equal to 10. Ten is given to us. I'm also going to put above this some letters to go with it because it's good to be able to write it that way as well. Our side length AB is equal to BC, not multiplied by the square root of 2, but divided by the square root of 2. Okay, so there's a couple different ways I could write an equation to go ahead and solve it. So these are both true. They're both somewhere you can start. One may make more sense to you than the other. The side AB is x. The side BC is 10. I have to divide 10 by the square root of 2 to get x. And we are going to do that. And divide by the square root of 2 and the square root of 2 on both sides. Square root of 2 divided by the square root of 2 is something divided by itself, so that's always equal to just 1. And then what I'm left with is x is equal to 10 over the square root of 2. So I have isolated my variable. X is by itself. But there's a problem with my answer. Okay, so the issue here is that we need to rationalize our denominator. Okay. You cannot have a radical in the denominator. Okay. But you can have a radical in the numerator. Okay, so maybe you want to type that into your slide or add that into your notes. But this is why we need to this is why we need to rationalize our denominator. I was answering a message. I got it like mid-thought, I got distracted. Okay, so we can't just leave our answer as x equals 10 divided by the square root of 2. That can't be our leg length. We need to rationalize it. Now, to rationalize it, we got to get that square root out of the denominator. How do I do that? We just saw this in the video for our warm-up. How do you think we can get rid of the square root in the denominator? Nobody knows. Think of it this way. What could I multiply the square root of 2 by? Yes, multiply it, multiply it. Okay, good. What could I multiply by to make the square root of 2 not have a square root symbol? By itself? Yes, absolutely. Okay, and that is what we're going to do. So I'm going to multiply, and what color should I use here? Such a difficult decision. I'm going to use, whoa, what happened? Okay, let's use orange. No, I already used orange. Let's use white. Why not? Get on the right tool. There we go. Okay, so I'm going to multiply by the square root of 2. Okay, in the denominator. Because the square root of 2 times the square root of 2, that just gives me 2. That's what I want. But anytime I multiply by something, I have to make sure that, I'm not changing the value of thing. This has to equal 1. So in order for it to equal 1, what should go in the numerator? In order for what I'm multiplying by, that has, right now it's written in white, the square root of 2. Yes, what should go in the numerator? Anjali and Veronica, you're right. And Adriana, you're right. The square root of 2 should also go in the numerator. Okay, because anything divided by itself, or in a fraction, numerator and denominator are the same, that's equal to 1. Okay, so you can always multiply by 1 to manipulate things so that way they look a certain way. Okay, square root of 2 times square root of 2 is the square root of 4, which is just 2. In my numerator, 10 times the square root of 2. Okay, so I got that radical out of the denominator. It's in the numerator. It's fine in the numerator. There's only one thing left that I can do. 10 and 2, there's something I could do there because 2 is a factor of 10. So we can rewrite it a little bit differently one more time, and then I'll have a completely simplified answer. What should I do with 10 and 2? Divide. Yes. 10 divided by 2 is going to be 5. So we get 5 times the square root of 2. That's our answer. That's what x is equal to. This is, oh, why did I use blue? Let me undo that. I'm supposed to use pink. So x is equal to 5 square root of 2. X is equal to 5 square root of 2. And we have now solved the right triangle because we know all 3 angles, we know all 3 side lengths. This is the hypotenuse, 10. And then the 2 leg lengths are 5 square root of 2. Do you guys have questions on that? So I'm going to put you on student page.